winding. So we'll discuss what is meant by lap winding and what is meant by wave winding. Okay, so in a note, so what is meant by lap winding and as well as the wave winding. So if you go for the armature windings consisting of a two methods. Background, where is this? So this is color only. Okay. Now, so armature windings are two types. One is called the lap winding and another one is wave winding. Lap winding and wave winding. If you go for the lap winding, number of parallel paths is equal to number of poles. So where A is called the number of parallel paths. And P is called the, we already know that it is a number of poles. If you go for the wave winding, number of parallel paths is equal to 2. So how it will be wounded? Now see here, if you go for the lap winding, if I am going for the 24 slots in the 4-pole machine, 24 slots, 4-pole machine. So 1 to 6 and 7 to 12 and 13 to 18 and 19 to 24. So what is this 1 to 6 is called the slots here. 1 to 6 is slots. 1 to 6 slots, it acts as North Pole, South Pole, North Pole and South Pole. So the starting end of the coil is placed in the first one and the finishing end is placed in the 7th one. Okay, finishing end of the first coil is placed in the 7th, and the event once it will come back here, once it will be come back to here. Oh, sorry, wait, I think it is struck now. Okay, once it will be come back, then we can say that it is a lap winding. So it is written back. It is written back here, and also it is placed in the second slot, and also it is placed in the 8th slot, and also which is written back and the 3rd slot, and like that you can wound the windings. So this type of winding is called the lap winding. Okay, the finishing end of the first coil, is placed in the same poles. Okay, that is called the lap winding. It is written back to ఇది ఏదైతే హోమ్ ఉందో అక్కడి నుంచి ఎక్కడైతే స్టార్ట్ అయిందో అక్కడికే రిటర్న్ బ్యాక్ అవుతుంది. దాన్ని మనం ల్యాప్ వైండింగ్ అంటాం. అదే వేవ్ వైండింగ్ అంటే ఏంటంటే, ఇఫ్ యూ గో ఫర్ ది వేవ్ వైండింగ్, so what is meant by wave winding means same 1 to 6, 7 to 12 and 13 to 18 and 19 to 24. All these are called slots only. If you go for the slots, it acts as a north pole and it acts as a south pole, it acts as a north pole and it acts as a south pole here. So we can place the starting end of the winding in the first slot and the finishing end is placed in the second slot. Now this finishing end, starting end of this second slot, second winding is placed in the third pole. Just like a wave, it is moving. So third, and like that it will be going. Like that, it is a wave winding. For this, if you mount the winding, for this winding, the number of parallel paths is equal to number of poles and also number of brushes also. Number of brushes are very, very important. These type of questions only he will ask. Number of parallel paths is equal to number of poles in a lap winding. ఓకే, ప్యారలల్ పాత్స్ అంటే మీకు తెలుసు కదా, అవునే నెంబర్. ఇప్పుడు సపోజ్ 4 పోల్స్ ఉన్నాయి అనుకో, ఎన్ని ప్యారలల్ పాత్స్ ఉంటాయి? 4 ప్యారలల్ పాత్స్ ఉంటాయి. అంటే అన్నీ మనం ప్యారలల్గా కనెక్ట్ చేస్తామని అర్థం. ఇక్కడ నెంబర్ ఆఫ్ ప్యారలల్ పాత్స్ is equal to A is equal to 2 irrespective of the poles, irrespective of the poles. Okay, and the number of brushes is also equal to 2. What are the number of brushes? Number of brushes are equal to 2 here, and so this is very, very important. So if you go for this one, you go for difference between the lap winding and wave winding. Lap winding, and this one is called the wave winding. Okay, so lap winding means number of parallel paths is equal to number of poles, and here number of parallel paths is equal to 2. So I will tell you one small story here and here. So if I am taking a 4 coils here, 4 coils, okay, and each coil carries a current of 1 ampere, and let us say this voltage is 10 volts, and here also it is 1 ampere, and this will be 10 volts here, and here also it is 1 ampere, and the voltage which is appeared across this one is 10 volts. Now if I am connecting it in 2 are connected in series here, 2 are connected in series, and the remaining 2 are connected in series, and the net combination is connected in parallel. Net combination is connected in parallel. Now what is the current which is flowing here? It is satisfied or not? Each coil is 1 ampere. Yes. So what is the voltage which is appeared here? 10 volts. And what is the voltage which appeared? 10 volts. And what is the voltage which is appeared here? 10 volts. And here also 10 volts. Here also 10 volts. And now, so how much voltage? Voltage output is 20 volts. Voltage output is 20 volts. And if I am connecting, all are connected in series, if I am connecting all the windings are in series, what will happen? So this is coil 1, coil 2, coil 3, coil 4. So now each coil carries a current of what? Each coil carries a current of 1 ampere, and this one is 10 volts, and this is also 10 volts, and this is also 10 volts, and fourth one is also 10 volts. How much voltage are you getting? Is 40 volts. And if I am increasing the number of parallel paths to 4, if all are connected in parallel, okay, so in parallel the voltage is same, each coil carries a voltage of 10 volts or not? Yes, parallel voltage is same. So each coil carries a current of 1 ampere, 1 ampere, 1 ampere. So what is the total current now? What is the total current? Total current is 4 amperes here. 1 plus 1 here, it is 2 amperes. What is my observation here? So if I am increasing the number of parallel paths, you can see number of parallel paths, the voltage value will be, so if number of parallel paths A increases, what happened to the voltage value will be decreases. If a voltage value will be decreases here, and also the current value will be increases. So this is the best example for the wave winding here. So I think you understood, right? Wave winding is equal to parallel paths only. Number of parallel paths is equal to 2. And here I am taking 4 pole machine, right? Yes or no? 4 parallel paths. 4 parallel paths. So what is my observation is, if a number of parallel paths is equal to number of poles here, number of parallel paths is equal to 2, that means it is suitable for low voltage applications. It is suitable for low voltage and high current applications. And it is suitable for high voltage and low current applications. Okay, so low voltage and అనకూడదు, low voltage కామా అనాలి, ఎందుకంటే it is not a transformer కాబట్టి. So low voltage, and here also same thing, high voltage comma low current, low voltage comma high current applications. So lap winding, number of brushes is equal to number of poles. So number of brushes is equal to number of poles here, but here number of brushes is equal to 2. So he will ask in an examination, number of brushes in a lap winding is dash, which is equal to number of poles or not, and which is not equal to number of poles. And for a 2-pole machine, or for a 4-pole machine, for a 6-pole machine, number of brushes is equal to 6. For a 4-pole machine, number of brushes is equal to 4. For a 2-pole machine, number of brushes is equal to 2. And here for a 4-pole machine, number of brushes 2. For a 6-pole machines also 2. For 8-pole machines also 2. Okay, so this is the difference between the so then this is the difference between lap winding and as well as the wave winding. So lap winding as well as the wave winding. Okay, so now